Okay, so today we're going to be looking at similarity and what are similar shapes. So here we go, it's a lovely scalene triangle. Now the basic definition of similar shapes then is that if I just duplicate this, there we go, is well, these are congruent at the moment, and the basic definition of similar shapes is that one shape is an enlargement of the other. The more mathematical description or definition would be that all of the angles are congruent. There we go, nice three congruent angles. And the ratios or the corresponding sides are proportional. So if we call this A, B, C, let's call it A dash, B dash, C dash. What we should find is that AB all over A dash B dash should be equal to any other proportion, AC over A dash C dash or BC over B dash C dash. I'm sure you all know that already. Let's take an example then. Okay, we've got a nice right angle triangle. And what we're going to do is make another similar shape to this one. We're going to multiply the lengths of the side by 2. Just to make it nice and easy, let's see if I can count these squares. 3, 4, 5, 6, 7, 8, 9, 10. Does that look right? No, I think I've missed one. There we go, 10. And then you're going to have to make this 8 to make sure that they're proportional. There we go. Super, drawing our right angle, 10 and 8. Now in the first triangle we found root 41 using Pythagoras' theorem. So what we can do is actually check the hypotenuse in this enlarged triangle and make sure that the hypotenuse is double the length of root 41. So what we should get here is 2 root 41. Let's just check that out then. If we just call this x for now, we'd say x squared is equal to 10 squared plus 8 squared. So x is equal to the square root of 164. And it turns out that 164 is actually the same as 4 times 41. That's handy. And then if we separate those, root 4 times root 41, we do indeed get what we need. 2 times root 41. Super, so we can see all of those lengths are proportional. 8 over 4 is equal to 10 over 5 is equal to root 2 over or it's equal to 2 root 41 over root 41. Let's go back on those. The other thing to note about similarity then is not just the proportional side lengths, but also the area. In this one, then the area of this triangle is going to be base times height all over 2, which is, I'm sure you'll get 10. And then what do you think the area should be for this one? Should it then be 20? Let's check it out. 10 times 8 over 2 is actually 40. So what's going on? I'm sure you probably know this already, is that if we've multiplied by 2 each length, then when we go from 1 dimension, i.e. length, to 2 dimensions, area, we're now going to not multiply by 2, we're going to multiply by 2 squared. Okay, next we're going to look at an example then. So here's a quick question. So it's in the figure, DE and AC are parallel, very important. Let's draw that in. AC equals 10, blah, 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 blah. Find BE. So we can use our knowledge of proportional line segments to show that straight away we know that, well, these angles must be equal. There we go. And we also know from proportional line segments that, considering that DE and AC are parallel, BD over DA must be equal to BE over EC. But what we're actually looking for here then, when we're talking about similarity, are two similar triangles. And I think we can all see then that triangle BDE is going to be similar to triangle B, now make sure you get these letters right, BAC. And what symbol do we use for similarity? It's, pardon the pun, it's similar to the symbol for congruency. We just use the little squiggle that's on top. So it turns out actually, even without the proportional line segments, that any triangles, or any two triangles that have the same angles, or that have congruent angles, are then considered to be similar. So if these two are similar triangles, how can we then find BE, which is X? Well, we're going to use our proportional corresponding sides. So what we can say is that we know 4 over 10 must be equal to X over, now what do you think it's going to be here? A classic mistake would be to see that 4 over 10 is equal to X over 9, but actually it's going to be equal to X plus 9. That's because 4 is the side of the smaller triangle and 10 is its corresponding side, and then BE again is the side in the smaller triangle, but all of BC would be the corresponding side to BE. And then if we go on and solve that, then now we're just into algebra, we're nothing to do with geometry now. Multiply each side up, 4x plus 4 times 9, 36 is equal to 10x, and then 36 is equal to 6x, and there we go, x is equal to 6. Then just to round up what we've learnt, we said that two polygons are similar if their corresponding angles are congruent and the lengths of their corresponding sides are proportional. And we also now know what symbol to use if we want to say they're also similar. Okay?